Okay, Troy, we're going to talk about some winding protection devices. Basically, there's about 5 or 6 different ways we can measure temperatures to monitor a winding to make sure that the insulation isn't going to burn out. Okay. One of the most simplest ways is to install what we call a thermal protector. This is manufactured and made by a company called Klixons. And basically what it is a bimetal strip with 2 points with contacts on the end. And when it heats up, it basically allows the contacts to separate, and then when it cools, it comes back together and makes a path. So there's a circuit that goes from here through here unless we heat this up. These are rated for a specific temperature to open at. So in this case, where we rewind a stator with a Class F insulation, it's 155 degrees Celsius. This particular thermal protector is 145 degrees Celsius. So what we're trying to accomplish is to have this device open up the circuit and tell us it's got an alarm, or to shut off the contactor that's supplying the voltage to the motor at about 10 degrees Celsius before the winding starts to smoke or have a problem. So if these go into overload, the motor actually goes into overload and the current goes up on it, the thermal protector will start to get hot. It'll open, it'll shut the motor down if it's connected to the contactor. After it cools, they can reset the contactor and start it back up. Sometimes there's nuisance trips based on there's too much heat in the room where the motor's at. It could be 110 degrees outside. The room is got a air compressor that's putting out a lot of heat in the same room. For some reason, it may not be a problem really with the motor, but the temperature around the motor has climbed so high, and the actual operating temperature of the motor caused the thermal protector to get hot and then open up. So sometimes it's just a problem with the air in the room itself. Other times the motor's overloaded, pulling too many amps, and we're trying to save the motor from burning up by giving it time to shut down, let somebody go find out what's going on, cool off, and then restart. These come in a normally closed or a normally open position. When a motor comes in, you need to put an ohm meter across here, like this ohm meter. And all we're going to do is put it on ohms, so you can actually see it right there. And when we short out the 2 leads here, we should get roughly 0, just like that. When we put it across the thermal protector, we're looking for either a normally open or normally closed. So in this one right now is just the value of what this little piece of copper is, that 0.1, but it's showing basically shorted, closed. If this was reading across just like this with the 2, with no resistance reading right now, you would have to heat this up with our heat gun and see if it opened or closed and gave you a circuit, because that's the only way you're going to know if it's normally closed or if it's normally open. So real important, because if you put in this one, which is normally closed, and the guy had a normally open, as soon as he wires it to the circuit, something's going to happen bad. So in other words, either the alarm's going to go off, his circuit's going to shut down. It's in exact reverse of what we have here. So normally when this one opens, it lets him know he's got a problem, and when you put one in it that's reverse of it, he goes he goes right into a problem immediately. Okay, so the big thing here is to just make sure that we know what type it is that's in the motor. Use a heat gun to warm it up. You don't want to burn it. All you're trying to do is get it up to 250 degrees roughly in that area, and it should open. And then your meter will just show no path. And after it cools, you can take a reading again and show it closed, so you know it's working. Okay, real important to do.